Hello and welcome to my another video. Today's topic and demo is around Azure Active Directory App Proxy with the Web Access Firewall as Akamai, and we would be demoing Publishing Outlook Web Access. Those who are watching this video for the first time and who have not watched my other videos, just a quick introduction. My name is Atul Raizada. I'm a Microsoft Cloud Solution Architect. I've been helping customers with a variety of their workloads in Azure, especially around identities and security related issues. And this is one of my hobby and passion to create these videos and share with the community. These particular videos have no marketing or business objectives. It's purely for education purposes, and I hope this helps the community. With that, we need to dive into today's topic, and as I said that I would be demoing the publishing of Outlook Web Access with Azure Active Directory App Proxy, and as well as we'll also see that how does Akamai can work in front of it as a very powerful web access firewall. With that, let's continue our discussion here. And the next slide should actually show you the flow that how does Azure Active Directory Application Proxy works. And for those who have not experienced or who have not worked on Azure AD App Proxy, in a very simplistic way, we can say that Azure Active Directory Application Proxy can work like a DMZ for customers' production environment, and the DMZ is being delivered through Azure, right? So instead of a conventional DMZ that we have in production environment, this could provide the similar functionality as a traditional DMZ provides for allowing application access, right? So with that context in mind, what actually is happening with Azure AD Proxy, right? And before I actually dive into that, many of our customers have been facing challenges with aging technologies, like if you are familiar with ISA, Microsoft ISA, or TMG or UAG, which Microsoft has discontinued for quite some time, and some customers still have traces, and the applications running behind these appliances. For them also, this is an opportune movement to change their architecture and design of publishing those applications successfully with the help of Azure Active Directory App Proxy and replacing those older technologies, right? So this is also in the context of adopting new technologies in the light of the other old aging technologies like UAG, TMG, and IIS. And pretty much it's a very simple and straightforward approach, right? So when we talk about Azure Active Directory Proxy, and we will be demoing in next few minutes, you create an Azure Active Directory Proxy app that you obviously create in Azure Active Directory that has a URL. The users are pointed to that URL to access the application. So step number one, when user needs to access that application, users obviously puts that Azure App Proxy URL into the browser. Azure App Proxy comes back to the user with a token and saying, hey, I'm going to send this token to an Azure Application Proxy Connector. This connector is installed in your on-prem environment, and we will talk about the requirements and specifications around this Application Proxy Connector in the next few slides. But the user is now taking the token all the way up to the Application Proxy Connector, which is sitting in your production environment. And this is very important because it's Azure Active Directory Application Proxy is also acting like a reverse proxy. So the user session is terminated here, right? So user is not going to make a direct session on your application service that is running inside your network. And that is one of the big advantage of using Azure AD Proxy. That's where you see that this particular technology is a nice and good replacement of the technologies that I mentioned earlier, like UAG, ISA, and TMG, right? So this is where the session is terminated. And as a step number 4, now this application has to authenticate, and depending on what authentication method we are using, if it's a single sign-on, and we are going to dive into that a little later, It's going to talk to the Active Directory to get the token converted into a Kerberos packet so that Active Directory can authenticate. And many of you may already be familiar that Active Directory can only use LDAP or Kerberos as a protocol, authentication protocol, while Azure Active Directory has got many other options. And I'm not going to go in those details. If you need to see those details, you can watch my another video which is around Azure AD Domain Services, and you will find more details around that, what authentications are supported by on-prem Active Directory and Azure Active Directory Domain Services. Let's not divert ourselves into that discussion. And as a step number 4, the authentication request goes to Active Directory. Active Directory looks into that Kerberos packet, which is what the application proxy is actually doing in the background, converting the token into a Kerberos packet that Active Directory can understand, and in turn Active Directory authenticates back to the application proxy. At this point, in that step number 5, the application proxy connector establishes a session with the on-prem application server, comes back, and session is, as step number 6, is established back with the end user, and end user starts accessing the application. The key point that I mentioned earlier here, that user session is terminating and there are separate tunnels, right? So the one tunnel is between the user and application proxy connector, which is shown here with this dotted red line, which says number 3. And then a second tunnel is established, secure tunnel is established between the application proxy connector and application. As a result, from the security perspective, from the perspective of as a reverse proxy, the end user is not making a direct session on your application server. And that's a very straightforward thing. And many people who have used technologies like other reverse proxy services are very familiar with that. So it's no very different here, right? So that's the overall flow diagram around Azure Active Directory application proxy. This is a Microsoft diagram. So I have not done anything into this diagram, so credit all goes to Microsoft. Now, we also need to understand, when we want to deploy this technology into our production environment, that which applications are supported by Azure AD App Proxy. This is a question that has been regularly asked to me by different customers, and I think this is appropriate to talk about it at this point. Web applications that uses integrated Windows authentication are a potential candidate for Azure AD App Proxy. And please keep a note that when you use integrated Windows authentication, Azure AD App Proxy would also offer you the single sign-on experience, which is extremely important, right? So that's one of the biggest use case where you will find the utility of Azure AD App Proxy. Services that can use, or app services that can use Windows integrated authentication, are the perfect candidate for Azure AD App Proxy. Second category would be the web applications that uses form-based or header-based access, right? It's straightforward. Third case would be the web API that you want to expose to rich applications on different devices. I have never tried that, but this is good point to be noted. Applications hosted behind a remote desktop gateway. And lastly, the rich client apps that are integrated with Active Directory Authentication Library, ADAL. Again, I don't have any experience with the last bullet point as well. Hopefully I'll get some chance to test it. So very straightforward. It covers a wider range of applications that could be used with Azure AD App Proxy. And with that, let's try to look into the requirements for our connector. So the first important thing, depending on how your networks are set, especially from the security perspective, that Azure AD Proxy connector needs to be open for outbound traffic for port number 80 and port number 443. And I think most environment does that outbound traffic is generally open. But if your firewall or proxy allows the DNS whitelisting, then either you have to allow all the Azure Data Center IP ranges, and you can also use the URLs that has been given here down. I'm not going to read all of that for you. And that is the requirement from the port perspective, right? The next important thing is the capacity planning for Azure AD Proxy. And depending on maximum transactions per second, right, TPS here, you can define the size of your, or you can specify the compute requirement for your servers that would be running the Azure AD Proxy Connector. Keep in mind, when we do the Azure AD Proxy Connector that we're going to demonstrate in a few minutes, they have an automatic load balancing in the connector group, so you can have multiple servers running Azure AD Proxy Connectors, and they are automatically load balanced as long as they are in one same connector group, right? So, but this gives you a fairly good idea that what are your requirements to go forward and plan and design, you deploy your AD proxy infrastructure architecture in your environment. So folks, let's look into our lab, very high level design here. So what I have in my lab is a Windows Server 2012 R2 domain controller, which is hosting az.local Active Directory. Then I have a server here called as an LGL VPN az.local, which is actually serving two purposes. It acts like a routing and remote access VPN gateway, so creating a site-to-site VPN with Azure, and then it also is running my AD Proxy Connector for this demo purposes, right? And then I have an Exchange 2013 server running in my lab, which is serving the client access server and the mailbox server role, which is providing the OWA capabilities, which is what we're going to test today. And lastly but not the least, the URL for my Exchange 2013 public URL is webmail.aztest.club. Internally, actually, I'm using webmail1.aztest.club. No specific reason for that. It is because of the limitations I had in my lab for certificates and other challenges. So it could be anything. It could be webmail or webmail1, but I had a certificate for webmail1 available. That's what internal URL is webmail1, while external URL is webmail.aztest.club. Now, as far as Azure is concerned, in Azure, I have created a Azure AD Proxy app, which is called as an AZOWA, with default URL for this is webmail.azatlab.msfproxy.net. We're going to see it in a few minutes. But the external URL that I have published here is webmail.aztest.club, right? There is a specific reason for this configuration to accommodate the Akamai piece into that. And I'm running an Active Directory Federation services in Azure in this 2012 R2 server to provide the single sign-on capabilities, right? And as far as the Akamai is concerned, Akamai property is configured with the webmail.aztest.club. Is C name is pointing to webmail.hkey.net, and the host name is obviously a webmail.aztest.club, and the origin server that it will be talking to the Azure AD App Proxy, right? So this is our lab, and at a very high level, what's happening in this scenario is that the user is going to webmail.aztest.club in the browser. Webmail.aztest.club is C-named to webmail.hkey.net, which is the Akamai Edge server fabric, right? So it hits the Akamai server say, okay, where do I need to send it? Which is my origin server? Origin server is webmail.azatlab.msfproxy.net. It comes in here. Azure AD App Proxy looks into, hey, what is my connector group? What is the connector being used by this app? The connector is this LGL VPN. What is the URL that I need to use for this internal URL? Webmail1.aztest.club. And what I'm going to use for the external URL, which is https webmail.aztest.club. Please note this external URL is important here, because Azure AD App Proxy would accept the traffic and only from the browser, which is sending the header information as webmail.aztest.club. So if somebody else tries to do anything else and hits the server, ADFS proxy is going to refuse that session completely. That is the setting that we have in the lab, and let's see. I think we are now ready to get into the demo, and here we go into the demo. All right. So folks, here we go. So I have a Hyper-V server that is running in my basement, and if you see here, this is the AZLGL-DC02 is my domain controller that I showed into my video, and here is that server. And if you go here, just to quickly show you, that's the az.local, and I have got a couple of users here created that are syncing to Azure Active Directory here, right? And we are going to use, for an example, this user is a good example. And as far as the UPNs are concerned, the UPN being used here is aztest.club, right, which is publicly resolvable UPN, and ADFS server is running as I showed you in my video. Where is my ADFS server? One second, let me bring ADFS server up. And that's our ADFS server, right? So you will see here, this is running in Azure as I demonstrated to you earlier. And if we go here, this is also part of az.local, ADFS, this is all pre-configured, right? So that's our server, and maybe we can install the AD Proxy Connector on this server just for demonstration purposes. And then we have the Exchange, on-prem Exchange server, which is AZEX, right? And that's where this URL is, webmail1.aztest.club, where the emails are open in Outlook Web Access. And lastly, but not least, I have got this server, which again referred into the Visio LGL VPN, which is actually serving as a site-to-site VPN gateway and also running the application AD Proxy application connector, right? So this is another one. All right, so this is our lab environment. Now, in order to set this thing up, trust me, it is not very difficult, it's very straightforward. So let's see what are our prerequisites or how we actually deploy the AD Proxy Connector for our OWA. So the first requirement to make sure that our single sign-on works, if you remember in the slide deck that I presented earlier, one of the requirements for single sign-on was to use integrated authentication, right? So either we could do with the PowerShell, or we need to go back into our Exchange server and we need to change the authentication on both the directories here, right? So OWA virtual directory, and change the authentication to integrated authentication. You could do in the GUI here, as you see here, integrated with Windows authentication is checked, or you could also do through the PowerShell. I'm not going to be talking about PowerShell here. I just want to give you the concept here, right? So on both ECP and OWA virtual directory, obviously, you need to make sure that authentication is integrated authentication. So that's the step number one, right? And the second step that we need to do from the Exchange perspective is that we need to make sure that SPNs are set accordingly, right? So because this would be using a delegated Kerberos authentication, constrained authentication from Azure AD App Proxy to provide a single sign-on. I'm going to show you in a second. In order to make it work, your SPN should point to the URL that you are using, right? So let me try to show you what I mean here. So folks, the command here that I use is set SPN-L and the server name, which is AZEX, and it queried the Active Directory and came back with all the SPN records that we have. The record that is in particular important to us for Azure AD App Proxy is the topmost, which is http webmail.aztest.club, which is what we webmail1.aztest.club, which we are going to use in Azure AD App Proxy, right? So this is what by default you may not have it, so you might have to use some separate command called the set SPN-S, right? And then define HTTPS and then server name, and that's how you publish it. I apologize folks for my dog being a little excited here. Hopefully he will not disturb us any further. So this is the command that you will set the SPN here, and I'm not going to run it because it's going to error out as I already did that. Once those two actions are taken care of, that means we have changed the authentication to the integrated authentication on the Exchange server, and we have also ensured that the SPNs records are created, then we are set from the Exchange perspective, right? That's the activity number one. The second activity is that we need to set the delegated controls authentication on the Active Directory. So then we are going to go here on the Active Directory, and we're going to look for that machine account for that server, application server. In this case, this is going to happen to AZEX, and AZEX is so go to the properties of this application server, go to the delegation tab, and I'm sorry, we need to go to the, I'm so sorry, I apologize. We need to go to the AD Proxy Connector, not the application server, right? So in this case, our AD Proxy Connector is LGL VPN. And here we go, and we go to the delegation tab. Make sure that you choose these options here. Trust this computer for delegation to the specified services only, and use any authentication protocol. That's where we are setting up the delegated constraint controls authentication. This is extremely important, folks. Without that, single sign-on would not work. And I have already added that, but just to show you what it takes is click add here, and you pick up your application server, which in this case is AZEX. Check the names here, and then you go and look for the HTTP, right? That's the thing that we need to add. And once you do that, because I already did that, I don't have to do it again. This is the task that you need to do to allow the single sign-on with the delegated constraint controls authentication. Extremely important step. If you don't do that, or if the SPN doesn't match, the single sign-on would not work, right? So please take a good note of this task here. So once we have done here, so we are set from the on-prem side now, and now we can move into the Azure side, right? So we can create an Azure AD App Proxy, and we can see that if it works or not, right? So let's dive into the Azure AD Proxy. So I'm logged on to my tenant here in Azure, and I go to Azure Active Directory, and we go to the enterprise application. As I demonstrated in my slide deck, this application is already published, but for those who are doing it for the first time, publishing this application cannot be simpler than this. You go to the new application, it tells you that the center blade here, on-premises application, configure Azure AD Application Proxy to enable the secure remote access. Click that. You define the internal URL, right? I'm not doing it because I already did that. I'm going to show you. You define, the name of the web app proxy, Azure AD App Proxy here, and then you define the internal URL here. And this is what we're going to discuss in a second, the external URL. Then we define about Azure Active Directory and click save, and it's done, right? So that's how you create that. Now let's look into our Azure AD Proxy app, right? So we go to the AZ OWA, and we go to the properties here. So the name is AZ OWA. Now at the top you see that enable for users to sign in, right? That's good here. And that's what we are asking the users to sign into Azure AD App Proxy, right? And that's what the single sign-on would kick in down the road. And then all of that stuff, we don't need to do that. This is automatically created by Azure once you create that Azure AD App Proxy. The two important things that you need to note down here, one is the user assignment required. If you click yes, then you need to go and assign the user into the user section that I'm going to show you in 1 second. I left it to no so that anybody can come in here without assigning the user. From the security perspective, if you're going to do it in a production environment, you might want to use it user assignment required, because then unless the user is assigned to this application, the user would not get access to this application at all, which is, in my viewpoint, is a good way to do it, right? And that means you can control the access to application based on the user assignment. So keep a note of it. I just left it wide open because this is a demo and production test environment. And then visible to the users, right? So this is also important. If you happen to publish myapps.microsoft.com, where you can see all the Azure applications that you have been publishing, whether it's a PaaS or SaaS or other applications, then this option would show this application into that My Apps. If you don't want to present it to the users in My Apps, then you can choose the No option here, right? So very simple, very straightforward, right? You are enabling the users to sign in here, and then you control the access to this application by the user's assignment, right? And then visibility to the user in My Apps. Now, if you decide to do the user assignment, you will go here, and there is actually a good PowerShell that I have used in past, where you can assign it to the bulk users, right? So you can define the users here, and that's the user assignment that we were talking about. So you click users here, you will see all the users from your Azure Active Directory, and you can start giving assigning the users right on this side, right? I'm not doing it this now at this point because I have decided to use it for all the users as of now. And then comes very important part here to make you understand the whole flow. So the internal URL is webmail1.aztest.club. Obviously, this name should be resolvable in your internal Active Directory DNS and pointing to your application server, right? So going back into our lab here, where we were demonstrating this one here, right? So if you go into this AZDLC, now this is where you would have the name here, webmail1, right? So this is where we created that, and that's where the records are pointing to. So if you ping here webmail1 .aztest.club, then it should point to 10.10.10.71, which is the actual IP address of my Exchange server, right? You see it here? So that's the DNS that you need to make sure that the DNS is perfectly pointing to the application. So that's one thing. Going back into the Azure AD App Proxy, this is the URL that you're going to put in there. Now, when you say the external URL, this is the URL that users would be given to, and users would use this URL to use and to get to the application, right? Extremely important. By default, when you would create Azure AD App Proxy, it would use the default msappproxy.net URL. So let me just show you here. So if you see here, by default, this would be the URL. You can change the prefix to anything that you like, and this would work fine. That means if you use this, you would have to share this information to your end user and say, you know what, if you need to access OWA, you need to go to webmail.azatlab.msappproxy.net. Most customers would not like to do that because this is not matching with their organization domain name. So in this case, you could use the custom domain name here, and my custom domain name here, as I showed earlier, is aztest.club. You can choose any prefix here, right? Now, this is extremely important to understand that you could have the same URL as internal and same URL as external. That means from end user perspective, they don't need to know any new URL to get to the OWA. You can change it to webmail1 and it will work perfectly fine. I did not do because of some certificate challenges in my area, so I'm going to leave it to the way it is, right? So webmail.aztest.club, it could be very well webmail1.aztest.club. Now the important point that you have to understand here is that your Azure AD App Proxy would only accept the packets where the header information matches with webmail.aztest.club. If you send it through anything else, it would not accept that packet and the connection would be dropped right here, right? So if I just try to go to the IP address of this particular URL, then it would just drop the session right away, right? Or the other important thing that is especially important in the reference of Akamai here is this webmail.aztest.club. If you look at the bottom here, right? So what is, if you are not using a third-party web access firewall, then one of the additional tasks for you to make it work for your user is that you would have to create a public CNAME record for this URL, webmail.aztest.club, pointing to webmail.aztest.msproxy.net, right? In our scenario here, when I'm also using Akamai as my front-end web access firewall, we do not need to do that. And there is a reason that we don't want to do that, right? And in that case, the way we would configure Akamai is our front end. So the certificate is at Akamai, and Akamai would connect to this guy here, right? And we don't need to worry about it. It allows us certain advantages to do that. Now, once we have understood this, that what is the internal URL, what is the external URL, what is the default external URL as msproxy.net, and as well as you can use the custom domain. Keep in mind that this custom domain would only show up those domains that you have already added successfully into your Azure Active Directory, right? So you are using Office 365 for that purposes. If you have got 5 or 6 domains already added there, those are the domains that you could leverage. If you want to change a separate domain here as a option for your Azure AD App Proxy, you would need to add that custom domain with the domain adding process into Azure Active Directory. I'm not going to detail that in this video, but most of us are very familiar with that process, that how do you add a custom domain into your Azure Active Directory. But that is a requirement to make the custom domain use. Again, for my scenario here, I'm not going to use the CNAME here. If you are not going to use Akamai, then you would need to create one more task here to use your public DNS CNAME record pointing to webmail.aztlab.msproxy.net, right? And then comes the next important configuration here, which is single sign-on, which is what we talked about with integrated authentication. So here you will choose integrated Windows authentication for single sign-on, and that's where the SPN that we created earlier on Exchange Server is going to be extremely important. This should match, otherwise single sign-on would not work, right? webmail1.aztest.club. And that's all we need to do into Azure AD App Proxy, right? Now, in addition to that, we can also configure conditional access here, or to make this environment more secure, we can also configure conditional access on this app. So if I go back into Azure Active Directory, security and conditional access, and here is my policy, right? Policy name is Atul. Users and groups assignment, actually I have added everybody here, right? And I'm not going to talk about conditional access policy. You can probably watch my another video which is on MFA, and that's where I have talked about more of conditional access policy. But let me make one change here to just demo. I have just excluded that because we were testing and it was asking us every single time. So let me just do that. So now every user is included, and here is what you can add or remove your application. So I have got multiple applications here, but Azure OWA, which is the application that we're talking about, is already added into this conditional Azure access, right? You can go into the locations, and what we are defining here is that you can grant access, but you would require multi-factor authentication. So now, from security perspective, what we are accomplishing here by this configuration, that users would come to AD Proxy, which is acting as a reverse proxy. So that's the session is terminated, but we are also enforcing the multi-factor authentication as a second layer of authentication. So now your application is way more secure than it used to. So this is a value added option in your solution, which your organization would like and love it, right? So that's the setting on the Azure AD App Proxy. Okay, now since and I think this is very straightforward. To be honest, to do all this process is probably less than half an hour work, right? Setting an SPN, setting integrated authentication, depending on how big your environment is. If you have got too many servers in your environment in Exchange side, it may take slightly longer. But Other than that, it is very straightforward. Now, the important part that we have not yet touched is installing an Azure AD Proxy Connector. So going back here, and you go to the Azure Active Directory, you go to the application proxy, and it's very straightforward, right? I've got many of them here, but you will say download a connector services. So for an example, on your machine, you would download this connector services and install it. By default, they are added into the default connector group, right? AD target.local is one of my default one, which is I added here, and it's active. And then you can create your additional connector group. So you can, this is a part of architecture that you have to define that, hey, I have this 3 or 4 or 5 different connector groups, and one connector group is for this application here or in this location or in this data center. Another application group is for this data center, or this application group is for this particular business unit here. So all that you have to predefine and in your architecture, that what this connector is or what this connector group is, what are the connectors. And as I mentioned, in one connector group, the AD proxy connectors are automatically providing you the HA capability or load balancing capability. So you can have 2 and they automatically are load balance. Right, so installing this connector is very straightforward. I don't think I should waste your time to show how to download and install the connector. Once you download it, you run the wizard, it will ask you at the end, I think, the credentials for that, for your Azure Active Directory. You sign in and then you're good to go. Very straightforward in my viewpoint. If this download is pretty small, I think it's less than 5 MB. Installation is very quick, very fast. I already showed you the capacity planner on AD Proxy Connector, your prerequisites for port. So before you start deploying it, make sure that you are meeting those prerequisites. All right. With that, as far as this is concerned, we are ready to start the solution and actually test it. Now, we can also quickly show you the Akamai piece here. All right, so this is our property in Akamai. And the first thing is that you need to create a property host name, right? So in our example here, our property name is webmail.aztest.club. Keep in mind, this is where the users are connecting to. So when the users are connecting to your Outlook Web Access, they are connecting to webmail.aztest.club. And actually, we create a CNAME for this, which is pointing to webmail.hkey.net, which is the edge servers for Akamai. So pretty much what we are asking the user browser, in order to access your OWA, is send all the traffic to webmail.hkey.net, which is hitting the Akamai edge server, fabric. And from there, the next activities start. Again, a certificate is required because we are using the secure option here on top, right? You can use without secure too if you like to. And in that case, you would need a secure certificate. This certificate is deployed on Akamai Edge servers. You don't have access to that. This is purely providing a secure tunnel, secure SSL tunnel between your end user and Akamai Edge server. This session is right terminated there. So actually, when we go with this route, you are providing a much more robust services through reverse proxy kind of a stuff here, right? And then once you have configured that, you have to generate the certificate request in Akamai. I'm not going to go in those details. And then you define your origin server, right? So origin server is, in this case, is going to be our Azure AD App Proxy. And if you remember here, I did not created a CNAME pointing to webmail.az-at-lab, but this is accessible. This DNS name is accessible. This is a public DNS record that is automatically created by Azure, and so that my Akamai Edge servers can directly connect this server. It's important to see here the incoming host header, because if we don't do that, our incoming host header would be the webmail.aztest.club, right? If anybody tries to bypass that and does not understand that, our Azure AD App Proxy would reject that, because the header information is not being sent here, and even Akamai would not work, right? So these are important settings here. And once you do that, you publish that, you activate, your solution is good to go, up and running, right? Now let's see this in real life. How does it actually work? So we're gonna go to webmail. Let's do it in a incognito windows because I'm signed in here as a different account. So let's start this. So we're going to go to webmail.aztest.club. And remember, when we are doing that, we are actually going to the Edge servers here, right? And Edge server is now sending it to Microsoft Azure AD App Proxy. And immediately, because we chose the option for users to sign in here, it is asking the user to sign in with their credentials here. We're going to do that. It's going to take me to the ADFS sign-on page. Very normal for all of us. We are very familiar with this. Remember, this ADFS server is running in Azure. All right. Now it should send me a text message. All right, so I think that process is still not kicked in, but in general it should ask me for a MFA text. I need to see what happened, whether I saved it or not, but that's the process. And now I'm in OWA, right? So pretty much working fine. It's published through Azure AD Proxy behind the Web Access Firewall. That's all this demo is about. And let me see if I can make the MFA work here. Give me a second, please. Yeah, so I have not saved it. That's the reason the MFA didn't kick in. Let's just make sure that now this is up to date and I'm not excluding this user. Okay, wonderful. Now let's see whether the MFA works now. So we're going to try one more time. What was my user? I apologize for this inconvenience. I did not save my policy there in Azure. And here you go. So MFA is now kicked in. And let's see if I get that. Perfect, right? So that works fine. Now let's try to approve a few more things here, right? So, and then we see what actually happens, whether our theory is actually working or not, right? So folks, as we discussed earlier, we are not creating a CNAME record for webmail.aztest.club pointing to webmail.azat, right? So this particular URL, let's see a couple of things here. First of all, let's try to ping and see the DNS record for webmail.aztest.club and making sure that what I just said is correct. So we do that. Right, that's the external URL, webmail.aztest.club, and where should it be pointing now? It should be pointing to the Akamai, which should be the edge key, right? So the alias here is edge key. Edge key is the Akamai servers. That's number one. Number two is that we also want to go and try to see that whether we can get this resolved. It should be resolvable because we didn't do anything here. If we go here and say ping, we got that IP here, right? So that's perfectly fine. Now what we also want to prove here, that because of our header information that we architected it properly, can we go and try to hit this webmail and get access to the application, assuming that somehow the hacker got the information that the users are trying to this application via the Azure AD App Proxy, and I can bypass that, right? So let's see here. Obviously, I think I would get a certificate error here. Let me just make sure, because I did not do that. If you are doing it in your production environment without Akamai, then not only you would create a CNAME record, but you would also publish your certificate in Azure, right? So I'll show you. I think I forgot to mention that. That's interesting. Let's just look into, if you do not decide to use Akamai and you just want Azure AD Proxy to be working, once you change your custom domain name here, you make a CNAME entry here, and then you also upload a certificate that has the CNAME included in that as webmail.aztest.club. That's what we were talking about, right? Let's go back and try to continue our test. So folks, if you see that it has, the Azure AD App Proxy has immediately dropped the connection because it is not matching the header information as webmail.aztest.club, right? You can try as many times as possible, because the way we ask, Azure AD App Proxy is expecting a header information as webmail.aztest.club. Because we have yet not provided that, that's the reason AD App Proxy is dropping this connection right away. This is as per design, this is what we wanted, and this is what we have accomplished, right? That's number one. Number two, if we decide to try, a hacker somehow gets the IP this, and I'm going to show you that why this would not even be possible now. If I even try this here, right, and I do this, obviously it's going to give me a cert error because I don't have the cert here, and I try to go here, it will still drop the session here because I'm not passing the header information, correct? So we are protected with that way. The only caveat that we have tested is that somehow we are smart, or a hacker is smart and create a DNS entry or a host file, and then we try to hit that. In that case, this user would be able to bypass Akamai, and we don't want that. So what we have done in Akamai interface and we tested it with our network trace to the Wireshark and Netmon and Internet Explorer debugging tools, that we do not expose this particular URL or IP address in our entire transaction or transport mechanism. So Akamai, we configured Akamai in a way that we would not let it happen. So you're absolutely protected. That means the users would not be able to get this information, and they would be forced to use Akamai. And once they come from Akamai, we have our entire and monitoring and filtering working behind it as a web access firewall. It hits the Azure AD App Proxy. Azure AD App Proxy takes it to the Azure AD Proxy Connector, and connectors let the connection made to the actual application as we discussed earlier. So that's all folks that I have for you today. I hope you find it interesting. This is extremely powerful solution. It replaces UAG, it replaces TMG, it replaces ISA, it also replaces other proxies, reverse proxy solutions that you are using. It uses the advantage of Azure Active Directory, single sign-on capabilities, also adds the conditional access policy so that you can turn MFA, you can control the behavior, you can also control the access to the users based on the user's assignment. So a pretty robust solution in my viewpoint. Please let me know if you have any questions, if you have any concern, or whether you like it or you don't like it. And I hope that would do it for today. Thank you.